Welcome to Developer Service YouTube channel. On today's episode, we're going to be continuing our NoSQL database that we created in the last episode. And on today's episode, we're going to be adding indexing and advanced query mechanisms like range, for instance. So if you have not done so, you can follow along with the Developer Server blog post from the previous article, creating your own NoSQL database in Python, or you can check out the previous YouTube video. Links in the description for both the previous blog post and the new blog post. Like I said, in this new blog post, we're going to be expanding our NoSQL database. So let's see how we can do that. So again, I have my PyCharm project with our database file and our main file and our test database that we used in the previous video. We're going to be doing changes in the database.py, which obviously contains our database. So we're going to be adding the indexing and also the advanced query mechanisms. So let's see the changes that are needed for that. So as before, we have our class JSON NoSQL database. We have our init method. One of the changes that we have here now is that it receives a new parameter, which is index fields, which by default can be none. So we're going to be passing to the NoSQL database which fields do we want to be indexed. And those index, we just simply attach it to a self.index variable. So that's obviously we can keep track of that. So not only we keep track of the index fields, but of course we also need to keep track of the index itself. So here we're initializing a dictionary with where the keys are the names of each of the fields, and we're setting that to the index. When we are loading our JSON file from the database that contains our database, we are loading as before the store. But now we're also loading our indexes, and we're just converting the ls indexes from a list to a set. This is what this code does. So it goes through each of the key of the value of the index items, and it sets that as a key. And then it goes through the field in the index on the index itself, and sets with the items. It sets the dictionary, reloading from the database the structure that was saved as a JSON file. So another of the changes that we have is, of course, in our save method to save the database. We have changed our structure. So now besides storing our store, we're storing our indexes. Here we're doing obviously the inverse that we're doing on the load. So we are transforming the set into a list so that we can save it into the database. So for each of the items, key and value, we're putting in the key where the value is list. And this is done for each of the fields that are part of the index. And of course, we're then saving it, the JSON file to the disk in this case. Another of the changes is in our insert method. Of course, after we insert the document into the store, we also need to update the indexes. And so we call an inner function the update indexes, where we pass in the doc ID in the document. And then, of course, we do the save method. Just as the insert method is changed, of course, also the update method needs to be changed. So again, after updating the document, we're updating the indexes by calling the self.update indexes. So now we have the update index functions itself. As we saw, it receives a doc ID and the document. We're checking for each of the fields in the index fields, so the fields that we want to index. We are checking if that field is present in the document. In case that field is present, we're storing the value of that field from that document, is storing in the variable value. Then we're going to be adding that doc ID to the index, because that's how the index works. And again, if that value is not already present in the indexes, then we're going to be adding that as an index, and we're in the index with the field and also with the value. We're creating a set with that. And then we're just adding to that set doc ID. So first, if it does not exist, we create a set so that we can then store with the combination of the field and the value, store that doc ID to the index. The get method has no change because we're just returning the document. The delete method also needs to be changed because after we remove the document, we obviously need to update the indexes also. In this case, we need to remove that document from the indexes. So we're not updating the indexes, but we're removing the document from the indexes. And then we have the remove index functions. As before, it receives a document ID and the document. And so we're going to have each of the fields that are part of the index fields. We're checking if that field is part of the document. If it is the case, we're getting that value. And we are checking if that value is indeed in the index. If that is the case, then we are discarding that value from the set, and the set is a combination of the field and the value. And if it is not present, then we can just delete that index from the set itself. So another one of the changes is in our query method. So we still have our previous query method, which receives a condition and just goes through all the documents and retrieves the document that matches those conditions. But we also now have a query by index method. This is again still relating to the index. So we receive directly a field and a value. So this is a very direct query by the index. We're checking if that field is part of the indexes, the indexes, so meaning the fields that we want to be indexed, and if the value is present in the indexes itself, then for each of the document IDs in that particular set for that field and that value, because to say the same index might have different document IDs, we're updating that to the results, and we're returning those results of the set of the document IDs that might match that condition and that might be in the index. It is worth noting that if the query by index, if the field and the values are not in the index for some reason, then that document will actually not be retrieved. That's obviously we need to use the previous query condition. So another of the changes besides the index is that we want to support more advanced queries. So we have precisely a function called advanced query that supports more advanced queries. So it receives a query function. So for each of the items that are in the store for the doc ID in the document, it's executing that function itself. That is the parameter that is passing. So it's the function that actually does the search on that document. And of course, if that query function is true, then it's going to append that document to the results and return the results. The same for we added also a range query that receives the field in the minimum and maximum value. So again, we're going through all the items that are in the store. And if that field, so the field that we're passing is if it's part of the document, and the min value and the value itself, the document field, which is the value of that field, is between the min value and the max value, then that means that the query is true, and we are appending that document to the results and returning the results. And finally, we are adding a composite query that receives a set of conditions, so more than one condition. Again, we're going through all the items and for all the doc IDs and documents. If all in all is one of the keywords in Python, if all the conditions that we have passed, if they are true for each of the conditions, so if all the conditions are true, then that means that the query is true and that document is appended to the results list, and we return those results. So now let's see an example of our database working with index. We're on our main.py file. So of course we're importing the database from the JSON NoSQL database. We're importing from the database file. We're instantiating the database instance. We're passing in the index fields. In this case, we're saying that we want to index the H field. We are inserting some documents as before in the previous video. And we are retrieving the documents by index. So we're passing in the field, which is age in this case, that we are indexing. We're passing in the value, and it should return the values of the document that belongs to that value. Let's execute the query. We execute it, and we see it has returned the document from the index that is matching that value that we are querying for. Before we see the examples with more advanced queries, let's see our database.json file to understand our structure is stored in the JSON file. So we have our store, which is our actual database, which is storing a document ID with the document that we have inserted, and the other document with a different document ID, and also the values that we have passed for the document. And then we have our index set, which has as a key that it's age, and inside that age it has two documents, the age 30 with a particular document ID, which corresponds to Alice, as you can see, and the other value corresponds to age 24, which is Bob, and the document ID that corresponds. So that's why when you search for age 30, it retrieves the index or the document ID that is part of that index, and then it returns the document that corresponds to that document ID present in the index. So now let's see an example of the more advanced queries. So again, in our main.py, we're importing our JSON NoSQL database from the database file. Again, we're instantiating our database with index field of age. We're inserting some documents as before. Again, setting Alice, Bob, and Charles with age 30, 24, and 28 respectively. And first we're going to do a range query. So our results is going to be our range query. So we're passing in the field age, and we're saying we want the results between 25 and 30. So it will return Charlie and Alice, and we are printing that results. Then we are going to be doing a composite query, which is a set of conditions. So as before, when we were doing the simple query, we're passing in a lambda function. In this case, it will be two conditions. So the first, we're going to say that our age needs to be bigger than 25, greater than 25, and that our name needs to start with an A. So for each of the names in doc, the name needs to be starting with an A. And we'll execute that as a composite query. We're calling in our function, passing in the set of conditions, and this should return Alice, which matches those two conditions. So let's run our query. And as you can see, for the first, age between 25 and 30 for our range query, Charlie has age 28 with his document ID, Alice has age 30 because it's inclusive, it's less than and equal. And for our composite query, Alice, its age it's greater than 25 and also that starts with an A. And this concludes our expansion of our NoSQL database. So as we saw, we added both indexes and several different types of advanced queries. We saw examples for range query and advanced conditions query. So like this video if you like this content. Subscribe to the channel for more content about Python, Django, and AI to be notified when that content is out. And until next time, happy coding!